Okay, this is day 4 notes, solving application problems using equations. Go ahead and find that in your packet. And it talks about 3 different kinds of application problems. We are going to focus on just the first 2, consecutive integer problems and applied geometry problems for our day 4 notes. So let's think about the word consecutive for a moment. What does that mean? Well, it's something that follows continuously, or one right after another. For example, if 5 is the first of 3 consecutive integers, then which 2 integers are consecutive from 5? So again, remember what integers are talking about. So the next consecutive integer from 5, we jump to 6, and then 7 would be my second and third. On the next one, it asks for the first, or that 5 is the first of 3 consecutive odd integers. So now in this scenario, what comes next? Well, we don't want the even ones, so from 5, we're going to jump to 7 and 9, since we want the odd integers that follow from 5. So in a generic sense, if n is the first of 3 consecutive, this time it asks you for even integers, which in a similar sense to odd is every other, kind of skipping over the one that follows right after. So if n is my first number, the even integer that would follow isn't 1 right after, but it is 2. So n plus 2 would represent the next even integer. And the one after that, again going back to that original n, I would have to add 4. So then I would have an n plus 4 as my third integer, and I would continue adding 2 each time. So take a moment, and on the second box here, if 12 is the first of 3 consecutive even integers, then what are my next 2? Again, we're back to this time even, so what comes after 12? That's an even integer, would be 14, and 16 is the third. So in general, if n is the first of 4 consecutive integers, now again, this is specifying for consecutive integers. It does not say even or odd. So if n is the first, what's the next consecutive integer? Well, I'm just going to go right after that, so n plus 1. The next one would be n plus 2, and the next one would be n plus 3. If n is the first of 3 consecutive odd or even, so it depends on the scenario, but they both have the same idea here. If n is my first number, how do I get to the odd? Or if n is the first number, how do I get to the even? I'm skipping over 1, so I'm going to add 2. And then again, I would add 4. If it helps to kind of see, maybe in this scenario with the 12, let's say n was our 12. Well, then how did I get to an even number? I knew that 12 got to 14, then 16. Those are my consecutive even integers. Well, with respect to n, 14 is 12 plus 2, and 16 is 12 plus 4. So how are you going to see these in a word problem? Well, if I look at the bottom box here, it says 4 consecutive odd integers. So the first thing I want to do is come up with a variable for what each of those are going to look like. So I have 4 of them. They are consecutive and they are odd integers. So my first one is going to be n. The next consecutive odd integer would be n plus 2. The next one would be n plus 4. And the fourth one would be n plus 6. Again, they're odd, so I have to hop over every other integer. And it says such that their sum is 336. So that would mean, now I'm going to go back to my variables. If I add all of these up, n plus 2 plus n plus 4 plus n plus 6, the sum is 336. So when you're solving word problems, you want to first identify your variables and then determine what equation I can set up to solve for what those variables would be. So now I have an algebraic expression here. I'm going to combine my like terms. I have 4n's. I have 2 plus 4 plus 6 is 12 equals 336. I'm going to subtract my 12 from the 336 and divide by 4. So I get n is 81. Now be careful on these questions. It'll ask you for a specific final answer. It says, what is the value of twice the greatest decreased by 3 times the least? So twice the greatest, so the greatest is n plus 6. So actually before I do that, I'm going to fill in what my integers are. So if n is 81, that's my first one, plus 2 is 83, 85, and 87. Those are my 4 consecutive odd integers. Okay, so it had said twice the greatest, so 2 times 87. Decreased is subtraction by 3 times the least, which is 81. So 2 times 87 is 174, minus 3 times 81, which is 243. And my final answer is negative 69. Go ahead and try the next box on your right and enter in your answer before you view the next part of the video. Okay, so as you can see from my work here, this time it was consecutive integers, so one after the next. You did not have to hop over to get to evens or odds. It was just one right after the other. So I did n plus 1, and n plus 2. 3 times the least, so 3n, minus 4 times the greatest, which was n plus 2, equaled 25. I solved for n. It was a negative integer. Negative 33 was that first one. Careful, it asked you for the middle integer, so that's why your final answer was negative 32. Moving on to our next page, going into some geometry problems. The length of a rectangle is 5 centimeters greater than its width. The perimeter of the rectangle is 58. So with geometry problems, I typically like to draw a visual. So I have a rectangle, so I'm just going to give me that shape to look at. The length is 5 centimeters greater than its width. So I'm going to call my width W, and the length of it is 5 greater, so that would be W plus 5. Now my equation says the perimeter of this rectangle is 58. So in order to find the perimeter, I would add up all 4 sides. So I have 2 widths and 2 lengths to get to my entire perimeter, which is 58. We know that opposite sides are congruent in a rectangle, so both widths are W, both lengths are W plus 5. Okay, once again, I have an algebraic expression here. I'm going to go ahead and solve. 2W plus 2W plus 10 equals 58. Combine my like terms, subtract my 10, and divide by 4. I get my width to be 12. Let's plug that back into the picture. The question does not stop at width. It asks you for the area of the rectangle. So if I plug my width in here, I know my width is 12, and then my length is 12 plus 5, which makes that 17. The area of any rectangle is length times width. So in this scenario, 12 times 17. The area is 204. Don't forget your units on word problems. Area is always squared, so 204 square centimeters. The second geometry problem to the right here says the sides of a quadrilateral are in the ratio of 1 to 2 to 3 to 6. The perimeter of the quadrilateral is 138. Same idea, different shape. So this time it is just a four-sided figure, and the sides are kind of getting bigger as we expand it out. So one of them is 1x, the other would be a 2x, a 3x, and then a 6x, all in respect to that same common variable x. If the perimeter is 138, I'm going to go ahead and add them. 1x plus 2x plus 3x plus 6x equals 138. Go ahead and solve that equation and then answer the final question that this particular problem asks for. So as you can see by my work, I got x equals 11.5. I plugged it back in to find the length of each of the four sides, 11.5, 23, 34.5, and 69 centimeters, which was the longest of the four. All right, the last type of geometry problems, we are going to look at angle measurements and the word supplement versus complement. So the measure of the supplement of an angle, remember supplementary angles add to 180, sum to 180 degrees. So the measure of the supplement of an angle is 25, more than 7 times the measure of the angle. So I'm going to go ahead and just give myself once again a little visual here. I have some angle here, and then I have another angle that together they sum to 180. I'm going to call my first angle just x, and then my other one is directly off of that one. It says the measure of the supplement of that angle is 25 more, so I'm adding 25 more than 7 times the measure of that particular angle. So the other one can be represented with a 7x plus 25. And what do I know about these two angles? Well, again, they're supplementary, so they must add to 180. So there is my setup. I'm going to go ahead and add x plus 7x plus 25 to get to 180. I get 8x plus 25 equals 180. Subtract 25, I get 8x equals 155. And divide by 8, we get a decimal 19.375. This one asks you for the measure of the angle and its supplement. So again, as I plug this back in to where our variables represent, the angle in question was the x, so 19.375 degrees. Again, we need units. And its supplement, which is 7 times 19.375 plus 25. Throw all that in a calculator, you'll get 160.625 degrees. And our very last question asks you about complements. Different than supplements, complements sum to 90 degrees. And it says twice an angle decreased by the complement of the angle is 36. So if I have twice an angle, once again, if we want to think about two complementary angles, visually they add to that right angle, so they make 90 degrees. We'll put them adjacent this time. Let's say here's my particular angle, and twice that angle decreased by the complement is 36. I'm going to name these differently because now I'm combining them to get to 36, not just the sum of 90 like the last one summed to 180. So I'm going to name the other one 90 minus x because that would be the complement, 2x. And now here comes my equation. It says twice that angle, so 2 times x, decreased, so subtract, by the complement of that angle, which is 90 minus x. Be careful here. If you are subtracting a quantity, you have to put that in parentheses. And we get 236 from that equation. we're going to go ahead and solve. 2x, distribute that minus sign. Minus 90 minus a negative x gets a positive, equals 36. Combine my like terms. 3x minus 90 equals 36. Add your 90 over. 3x equals 126. And divide, we get x is 42. What is the measure of the angle and its complement? Go ahead and answer that. And hopefully your answer matches my work as I've plugged it back in. The angle was 42 degrees and the complement was 48. That is the end of day 4 notes.